Welcome back to this final session on the learning path for packaging your AWS Lambda functions as container images. In this session, you'll learn some special considerations when packaging your Lambda functions as container images, things that you'll need to remember, be careful of, or do differently from packaging your functions as zip file archives. In this session, you'll learn about some considerations when updating your function code, things to keep in mind about operating system and runtime patching, how to work with Lambda layers using packaging as container images, and considerations when working with Lambda extensions. First, what do you need to keep in mind when updating your function code? Well, pushing an image to Amazon ECR doesn't update your function code configuration in your Lambda function. This is something that you will need to take care of yourself. This matters even if you're defining your function code by a tag, because the AWS Lambda service defines your function code by a hash of that image. Each time you push a new image, that hash is going to change. So you need to inform the Lambda service to update its hash accordingly. The best way to do this is with a robust CI/CD pipeline where you build, package, push, and redeploy your function in an automated fashion. There are also some considerations around operating system and runtime patching. It's important to note AWS no longer performs operating system and runtime patching for your images when you define your Lambda functions as container images. This is now your responsibility. Any change to the underlying operating system or runtime is simply a change to a layer on the image, and that means the entire image needs to be rebuilt, repackaged, and redeployed. It's also important to note that you will no longer benefit from any special access that AWS has on the base images that we use when running Lambda functions from zip file archive. For example, when the Spectre speculative execution bug appeared, all AWS Lambda instances were patched before it was released. You will now be responsible for monitoring and patching and updating those images whenever vulnerabilities occur. A few things to consider with AWS Lambda layers and functions packaged as container images. First, functions defined as container images do not support layers in the traditional sense. You cannot define a layer configuration on your Lambda function. Don't worry, all is not lost. Layers are just a build or deployment concept that allows you to package in additional information at deployment time that is then available to your functions at runtime. Well, since you're packaging your container image yourself, you can simply package in the same files and still have access to the functionality of layers. You'll just need to build those files in yourself. Previously, when the AWS Lambda service unpacked layers, it unpacked them in the opt directory in the root of your function image. You may choose to continue this practice when building your functions as container images, but it's not required, with an exception for extensions that we'll discuss. For an example of how to package layers into your container image at build time, see the blog linked on the slide at s12d.com/extensions. It's also important to note that since you're not using the AWS Lambda service concept of layers, you're no longer limited to including 5 layers in a function. Each layer is just a step in your Docker image build process, so you can have as many as you need. You're also no longer limited to 250 megabytes. You have that 10 gigabyte container image limit to work with. So how does it work to use Lambda extensions with Lambda functions packaged as container images? Extensions, like layers, are packaged at deployment and image build time, so you must continue to package them yourself using the Docker file. For an example of how to package extensions into your container image, see the same blog post. The most important difference to note is that extensions must be placed in the opt extensions directory in the root of your container image. So let's review what you've learned. There are some important considerations to be aware of when working with AWS Lambda functions packaged as container images. First, you need to know that when you update your function code and push it to ECR, you also need to update the service. Next, you're responsible for updating the operating system and runtimes yourself, as well as applying any other patches. And keep in mind, this requires another update on the service to point to the new image. Working with Lambda layers is a bit different because there is no longer a service level concept of layers, but you can package in as many as you need. And finally, you can also make use of Lambda extensions. You just need to make sure that you place them in the right directory. For additional information, check out the blog post referenced in this talk at s12d.com/extensions. And as always, more information on this topic and other serverless topics is available at serverlessland.com. Thank you for joining us for this learning path. I hope that you found this session, like the others, useful, and I look forward to seeing what you build.